Hey guys, welcome to this video. We will be discussing time series using Python. And here I have this small tutorial that I'm doing using real data and using Python coding. So stay tuned. What is a time series? If you never heard of that before, or if you're getting this started, a time series data is a data based on time. You have a data set that have a column, and that column varies over time. That time can be by month, can be by day, can be by week, whatever index uh, represent or whatever index kind of help the data go chronologically. That's what a time series is. Now, there are patterns, okay? There are patterns that that can be discovered in the data, and those patterns can be seasonalities. Let me give you an example. We all know that at the middle of the day, the temperature rise to its max, right? At 12 p.m. every day, you should expect the sun to rise. So the temperature is at its highest peak. It has a peak at 12 p.m. and then it dies down maybe after 1, and then it can go back up at 3 p.m. or 4 p.m. Then it dies completely down. So these are patterns that are can be discovered daily, and based on this pattern, we can make prediction, we can make a forecast, and forecasts are pretty much the prediction that we're talking about when it comes to time series. Now, um, there's one thing, important thing that we need to recognize as well, which is the randomness. And a randomness is always an important component of a time series, because when you look at the equation, and I have not put the equation here, we should always take into consideration the randomness. It's very important to consider that, because when you take the example of stock prices, these are hard forecasts to make, and they have to come into play. We, then you have a component, another component beside randomness is actually a component that can determine whether your forecast is good or not. Okay, and this needs to be addressed when you build your model. And then you have the data size. The more data you have in your in your model, the better. Okay, because the more information you have to train your model, the better. And when you talk about forecast, in order to build a forecast, it's always good um, to put more weight on the most recent data that you have, like the most recent years, and not on the previous, on the earliest years. That's the second part. And the first part also, a good indicator of a good forecast model is that you always want to remove exceptional data. What do we mean by exceptional data? And exceptional data is a pattern that is very unusual, that should never happen, but it has happened. If I go back to the example of the temperature, there may be during the summertime, you know, we may come up with a light snow, right? In any day of during the summertime, and this is very unusual. It may happen, but it's very unusual. So what are we going to do? This is at 12 p.m. Instead of the sun shining bright lights, we have a small storm of snow. Okay, and the temperature may go uh, close to 6 or 7 degrees. This is very unusual, but it doesn't happen all the time. This this specific day, or this specific time of the day, or this specific day should be removed, because it's a very unusual pattern, and if we put that into the model, it's going to create a problem. It's going to create a problem. So now, what are the relevant packages that we need to talk about? You definitely need stat models when you deal with Python. In R, R has a very complete library of packages, but with Python, a stat model is really what you want to use. Besides stat models, you want to use pandas and NumPy. All right. So we're going to be looking at forecast demand data, and let me see if I have the description of this data. So this is a forecast demand. Really, I had that from UCI machine learning repository, and it's a data set that has been collected during 60 days. Okay, it's a real data set that address that come from a Brazilian logistics company. Okay, and then you have multiple attributes in these data sets. You have the total order, which is really what I want to forecast, and then you have the index, which is the week of the month and the day of the week. So back to the data itself, what I'm doing here, I'm pretty much reading that data. It's a CSV file, and then I have a delimiter, and then I sort the data by the end the time. This is really what's defined the time series, the week of the month and the day of the week, as you can see here. Okay, so when I run this, it's pulling the data, and when I request the head of the data, this is exactly how it looks like. So we want to focus on these two columns first as the index. So this is the first week of the month, and this is the third day of the week. So this is Wednesday, and this is sometime the first week of the month. And then we want to look at the total order, which is the target. Okay, that's what we want to forecast. Now, let's look for more information about the data. What does the data have to tell us? Okay, so we have altogether 13 column and we have 60 rows. Okay, and I'm not gonna worry about anything else but the total orders because that's the purpose of our tutoring today. And so I have created here an index, which is the time index, because I want to be able to actually, I may not really need it, um, but let's still create it. What I'm trying to concatenate the first two column, make it one. Um, to so I can do my analysis properly. And when I get that, this is how it looks like. Okay, it's just two column put together and with a dash in the middle. But really, what I'm interested in, because I have to build a time series, I'm creating so this is it's not a true data, okay? I'm just trying to create to make it easy for this storing. I'm just trying to say, okay, the first value of my data start in January 1st, 2020, okay? And then the period is 60, so since it's the day of the week, okay? So it's a daily, but here I have put the frequency business frequency, daily business frequency. So, um, and then when I run this and I look at the tail of my data, I can see that, you can see the days here, but these are weekday, but these are business days. So I would say Saturday and Sunday will not count. All right, so this is the bottom of the data. So it started really in January and it stopped in March. So it stopped in March 24th. So let me take a look at the heads. And yes, it started January 1st, 2020, and stopped in March 24th. All right. So, what would be the first thing that you should think about when it comes to time series? Always check if there's white noise. What is a white noise, by the way? A white noise is just it's a random, it's pretty much the randomness that's in the time series. And you recognize it when you have some IDD. What I mean by IDD is independent um, observation, independent identical observation, and this is characterized by a mean of zero and a constant variance usually. Okay, constant variance of some people talk about variance of one. Now, if we have uh, this kind of pattern, then we conclude that there's no autocorrelation and there's white noise. So you cannot have autocorrelation of time series and whatnot at the same time. It's either or. So if you want to test if there's white noise, that means that most likely there's going not going to be autocorrelation. If you don't find any white noise, that means that most likely um, there is going to be autocorrelation. All right. So let's let's try to find out if there is white noise or not. Okay. All right. Again, we want to see that the mean is zero. All right. So here in this specific case, you don't see a mean of zero. The mean is 300, and then you see a standard deviation completely different than one. It doesn't sound like there's white noise and there's potential autocorrelation here. All right. Um, and this can be confirmed by, and I need, this is probably the time to talk about what is an autocorrelation. Autocorrelation really uh, state that the observation depend on each other over time. So the previous time, I mean the current event, I would say the current event or data point depend on the previous event or data point. So there is a kind of pattern that we see over time, and the observation depend on each other over time. So this is pretty much what autocorrelation looks like, and you can see here that there's definitely the observation are really around zero. You see it go up and down in a very steady way. And another way for you to notice is that if you have the same amount, about the same amount of peak on below and above the zero line, then there's a sign of autocorrelation. So um, yeah, this is we can definitely see that there's autocorrelation here, and since there's autocorrelation, then we conclude that there's absence of white noise. Now, this is the time now to visualize our time series. So I'm going to uh, uh, look at the cumulative orders. Cumulative orders, we take the orders and add them up together over time. So if the first element is, if the first order in January 1st, 2020 was 298, is going to add the order for the second, and this number is as of, so it's pretty much the first number, which is, if I go back to my data set, it's going to be 298.56 plus 539.77. Okay, so that's my second number. So it's an aggregation, it's accumulation over time. All right, so taking a look at that here, what I want to do, I'm pretty much putting the demand itself in one figure and then the cumulative order in the second figure. Okay, so that with that, I should be able to see what kind of pattern I'm dealing with. All right, so you can see the accumulation here over time, and you can see how the daily demand forecast is really acting over time. Now, what can be said about this graph? You can see kind of see some type of seasonalities. You see some peaks, definitely some peaks, and some lows as well. But you kind of see a little bit of trend. I'm not too sure, but you see a very slight trend, really not that visible. Okay, so here we can see that the trend is increasing. There's no white noise, uh, and the first step to your analysis, whenever you deal with time series, is conduct a stationarity test. What is a stationarity test? A stationarity test help you find out if the observed value fluctuate with a constant variation over time, and with around some type of overall mean. Okay, if that is the case, then we say that the time series is stationary. If that's not the case, then we conclude that this time series is not non-stationary, and then a first difference of transformation is required. And what do I mean by difference transformation? We're going to talk about it in our next touring. By the way, if you have not subscribed to my channel, please do so, because I have a lot of data science and statistical content that I put out there. And my website really is, and this is a kind of break, datasciencetopics.com. I have some free classes, and I have that I offer. You may see an amount, but you really don't have to pay for it. Um, and you have also you have some courses, Python for beginner. This is not completely popular, but it's still a work in progress. Please go ahead and subscribe for my channel. That's datasciencetopics.com. I have also a blog that can help you find answer to any question that you may have. Again, this is still being populated. Okay. Now back to our lab here. Let's run a test for stationarity. How do we run this test for stationarity? We have to look at the Dickey-Fuller test. The Dickey-Fuller test helps find out whether our time series is stationary or not. One way of doing that is to run some hypotheses. The first one, the null hypothesis says we say that the time series is not stationary, and the alternative we say that it's stationary. Now here's the codes for the Dickey-Fuller test. Here, what I'm doing is I'm calling the AD Fuller function that I had all the way on top, okay, from stat models, and then um, and then the criterion is the AIC. That's what minimize whatever mean square error or optimizer. And then here, these are the results that I want my test to spit. So I want the value of the test statistic. I want the p-value. I want the number of like, and I want the number of observations that have been used for this result. All right, so let's run this and let's look at the result of the test. Wow, you see here that we have enough evidence to to you know to support the fact that the time series are stationary. So we see that we have a stationary um, time series. Because we have a stationary time series, there is no need to do any transformation before we build our model. So um, again, this is what I wanted to show. I hope you like this video. This is the beginning of a time series analysis and forecasting. I hope you enjoyed this video. Please don't forget to subscribe, and I will see you next time to explain what will be the next step as far as building a model, looking at ACF and PACF. We're going to talk about this method, and also we're going to talk about how to transform the data when you don't have a stationary time series. Thank you very much, and I'll talk to you next time.